Hello students, today we shall continue with lesson 13, Carbon, an important element. Today we will be learning about hydrocarbons, properties of covalent compounds, saturated and unsaturated hydrocarbon, carbon dioxide, its occurrence, properties and uses, fire extinguisher, methane, its occurrence, properties and uses, and biogas plant. Hydrocarbons, basic organic compounds. Along with carbon, the element hydrogen is also included in most organic compounds. The compounds formed only from carbon and hydrogen are called basic organic compounds. These are also called hydrocarbons. The electronic configuration of carbon is 2, 4. If 4 electrons are added to the second orbit of carbon, its octet becomes complete and its electronic configuration becomes stable like that of the nearest inert gas neon, that is 2, 8. Therefore, the valency of carbon is 4. However, this occurs by sharing of electrons rather than a give and take of electrons. In other words, a carbon atom can form 4 covalent bonds with other carbon atom or atoms of different elements. When a carbon atom shares 1 electron each with 4 hydrogen atoms and forms 4 CH bonds, a methane molecule is formed. Here you can see the structural formula and the electron dot model of methane. Now let us see the properties of covalent compounds. Covalent compounds have low melting points and boiling points. Generally, they are insoluble in water and soluble in organic solvents. And they are poor conductors of heat and electricity. Saturated hydrocarbons. A carbon atom exhibits a characteristic property. It can form a chain of carbon atoms by forming covalent bonds with other carbon atoms. The hydrocarbons having only single bond between carbon atoms are called saturated hydrocarbons. For example, ethane, that is C2H6, and propane, that is C3H8, are the examples of saturated hydrocarbons. As you can see, only single bond between the carbon and hydrogen atoms. Unsaturated hydrocarbons. Some hydrocarbons have a multiple bond between two carbon atoms. A multiple bond can be a double bond or a triple bond. Hydrocarbons having at least one multiple bond are called unsaturated hydrocarbons. For example, ethene, ethine, propene, propyne. Here you can see double bond and triple bond between the two carbon atoms. Now let us learn about carbon dioxide. The molecular formula of carbon dioxide is CO2. Its molecular mass is 44 and its melting point is minus 56.6 degrees Celsius. Carbon dioxide occurs in the air in the free state to the extent of about 0.03%. Exhaled air contains about 4% of carbon dioxide, and carbon dioxide is present as a salt in chalk and Shabbat tiles. Carbon dioxide is given out in the combustion of wood and the fossil fuel coal. Now let us see how carbon dioxide gas is produced in the laboratory. Some pieces of calcium carbonate, that is limestone, is taken in a round bottom flask. The flask is fitted with a two-hole cork bearing the thistle funnel. Hydrochloric acid is slowly added through the thistle funnel. You have to make sure that the lower end of the thistle funnel is immersed in the hydrochloric acid. A chemical reaction takes place between calcium carbonate and hydrochloric acid, and carbon dioxide gas is gradually evolved. The gas is then collected in 4 to 5 gas jars by the upward displacement of air. Just look at the reaction. Here calcium carbonate reacts with the hydrochloric acid to give calcium chloride plus water plus carbon dioxide gas is given out. Now let us look at the physical properties of carbon dioxide. Carbon dioxide is a colorless, tasteless and odorless gas. It is heavier than air and sparingly soluble in water. Carbon dioxide neither burns nor supports burning. Now let us learn some chemical properties of carbon dioxide. When carbon dioxide is passed through an aqueous solution of sodium hydroxide, sodium carbonate, that is washing soda, is formed. And the chemical equation of this reaction is 2NaOH, that is sodium hydroxide, plus CO2, that is carbon dioxide. They react to give sodium carbonate, that is Na2CO3, plus water. When carbon dioxide is passed through an aqueous solution of sodium carbonate, sodium bicarbonate, that is baking soda, is formed. And the chemical equation of this reaction is Na2CO3, that is sodium carbonate, plus water plus carbon dioxide react to give 2NaHCO3, that is sodium bicarbonate, which is your baking soda. When carbon dioxide is passed through water, it dissolves sparingly, forming carbonic acid. That is, carbon dioxide plus water gives H2CO3, that is carbonic acid. When carbon dioxide is passed through lime water turns milky due to the formation of white insoluble calcium carbonate. And the chemical equation of the reaction is calcium hydroxide, that is CaOH twice, plus carbon dioxide gives CaCO3, that is calcium carbonate, plus water. Now let us look at the uses of carbon dioxide. Carbon dioxide is used to make aerated drinks, that is your cold drinks. Solid carbon dioxide, which is also called as dry ice, is used in cold storage and also to keep milk and milk products and frozen substances cool during transport. It is also used for getting special effects of a mist in dramas and movies. Carbon dioxide obtained by chemical reaction or kept under pressure is used in fire extinguishers. Liquefied carbon dioxide is used to remove caffeine from coffee. Liquefied carbon dioxide is used as a solvent in modern eco-friendly dry cleaning. And plants use carbon dioxide in air for photosynthesis. Fire extinguisher. Just look at the internal structure of fire extinguisher. A fire extinguisher contains sodium bicarbonate powder. There is also dilute sulfuric acid placed in a glass capsule. The capsule breaks on pressing the knob. The sulfuric acid comes in contact with the sodium bicarbonate and the two reacts chemically to release carbon dioxide, which comes out. Carbon dioxide based fire extinguishers do not cause corrosion and are non-conductors of electricity. Therefore, these are used when electrical and electronic equipment catches fire. Carbon dioxide based fire extinguishers are used to extinguish small scale fire. It is beyond their capacity to extinguish a big fire. In modern fire extinguishers, liquid and solid carbon dioxide is filled under pressure. On reducing the pressure, it becomes gaseous and comes out forcefully through the horn-like hose pipe. The chemical reaction which takes place is as follows. 2NaHCO3, that is sodium bicarbonate, plus H2SO4 sulfuric acid, they react to give Na2SO4, that is sodium sulfate, plus 2H2O plus CO2 gas. Methane. The molecular formula of methane is CH4. Its molecular mass is 16. Methane occurs in natural gas to the extent of 87%. Decomposition of organic matter in the absence of air produces methane. Methane is present in biogas. It is found in coal mines, and methane is found at surfaces of marshy places, which is why it is also called marsh gas. In the laboratory, When a mixture of hydrogen and carbon monoxide gases are heated at 300 degrees Celsius in the presence of nickel as a catalyst, methane gas is formed. Methane gas in pure form is obtained by fractional distillation of natural gas. Physical properties of methane. The melting point of methane is minus 182.5 degrees Celsius and its boiling point is minus 161.5 degrees Celsius. It is a colorless gas. The density of liquid methane is less than that of water. Methane is sparingly soluble in water. It is highly soluble in organic solvents like gasoline, ether, and alcohol. Methane is in gaseous state at room temperature. Chemical properties of methane. Methane is highly inflammable. It burns by reacting with oxygen to give a bluish flame. The chemical reaction of that is CH4, that is methane, plus oxygen gives carbon dioxide plus water plus heat. In this reaction, 213 kilocalories per mole of heat is given out. Here, methane burns completely. Chlorination. Methane and chlorine gases react with each other at the temperature of 250 degrees Celsius to 400 degrees Celsius in the presence of ultraviolet light and forms mainly methyl chloride and hydrogen chloride. The chemical reaction is as follows. CH4, that is methane, plus chlorine in presence of ultraviolet light gives methyl chloride, that is CH3Cl, plus HCl, that is hydrogen chloride. And this reaction is called chlorination of methane. Uses of methane. Methane in the form of natural gas is used in industries such as fabric mills, paper mills, food processing industry, petrol purification. Being the smallest hydrocarbon, the proportion of carbon dioxide released in the combustion of methane is small and therefore it is used as a domestic fuel. Methane is used for production of organic compounds such as ethanol, methyl chloride, methylene chloride, and acetylene. Biogas plant. Animal dung, dry leaves, wet garbage get decomposed by anaerobic microbes in a biogas plant. This produces methane gas, also called biogas. Biogas is a very cheap fuel option which meets the demand for cooking gas. It is also used for production of an electricity. Biogas contains about 55% to 60% methane and the rest is carbon dioxide. Biogas is a fuel which is convenient to use, and in addition to this, a very good manure is also produced as a side product of the process. Biogas production process. The production of biogas is an anaerobic process. It takes place in two stages. That is, first the production of acids and second the methane gas production. The microbes act on the biodegradable complex organic compound and produce organic acids. The methanogenic bacteria act on the organic acids to produce methane gas. And the reaction is as follows. CH3COOH, that is acetic acid, gives CH4, that is methane, plus carbon dioxide gas.